I'm going to get ready and put this thing in a case. But before I do, let me show you what I did here. When I installed the header pins, according to the instructions, for use as a signal generator, I installed a pin here called key, and I installed this row of headers, and I installed this row. Now I'm using clock 0 as an output, and of course there has to be a ground accompanying that to the BNC connector or to the output connector. So that's ground, and that pin's now used. There is a ground here that's used for the GPS receiver, and that pin is used. However, I needed, there's a ground right here, but that ground is being used by the encoder. The encoder is also S2, which is over here. So I don't need to install S2 on the front panel of the device because it's the encoder switch. In any event, that ground and S2 are used here. Well, I need a ground for the power supply, and I need a ground for S1. So I found out that these two pins, which I did not install, are grounded via the circuit board. That would be this one and this one. I installed a 2-pin header over here in these two holes, soldered it. And I'm using one of these pins now for my power supply. I'll use the second pin for S1. That is, I'll need to run a ground to S1 along with a wire to S1. Now I could have picked up the ground here from the encoder, but I just as soon not do that. Now this is the rear panel, and QRP Labs would have me put the RF output in the rear panel along with a power switch and a 9-pin DIN connector, which can be used. I'm going to use it for the GPS receiver. I'm going to put the power switch here just because it's pre-labeled. I'll put the encoder here so I can make use of this select label. I'm going to put S1, which is push button, here, and then here I'll run an SMA connector instead of using the BNC connector. The encoder push button is S2. So the red push button here will be S1. And while we're at it, if I mount it this way with these headers at the top, it'll be upside down. The correct way of installing this is with the 16-pin header, I believe. Anyway, the header to the display up to the top of the case. And just for the hell of it, I put a heartbeat here, which is synchronized with this LED display. Now, when you're putting this encoder in, there's a little tab here that probably should be bent flat or almost flat. Otherwise, this will go in crooked. See it sticking? Maybe you can see that. See it sticking out there. So bend that out of the way. The power wiring for this is really very simple. First, I took the power plug that came with the enclosure and soldered it to the end of a 5-volt wall wart. Now, QRP Labs cautions you that you need to provide a clean source of 5-volt power. Determine which of the 3 prongs, this is also supplied with the kit, is the center conductor. In this case, it's this one. And I ran a red wire up to the switch. And since I want this to be on, that means I ran it to the lower, well, I used the lower and middle terminals. I ran the red wire to the lower terminal. And the orange wire could have been a red wire. In fact, it should have been a red wire. I ran over to the 5-volt connection on the header. Then I determined which of the 3 solder conductors was the barrel, which is negative. And I ran a wire with a female connector to one of the 2 grounding terminals I've found. The signal generator, of course, is enclosed in the enclosure I purchased from QRP Labs. The GPS receiver is not, enclosure is not provided for it. Now, I don't know where this enclosure came from. There's no marks on the exterior. And there don't appear to be any markings on the inside. Rubber gasket. Captive stainless steel screws. And will the GPS receiver fit? I don't believe it will. I can probably, because the standoffs do fit, I can probably just Dremel a little bit of the circuit board away. So I'll do that. And the only thing else I have to do is mount a DB9 connector. But I haven't a clue as to where this enclosure may have come from. I just ground off a little bit of each of these 2 corners on the circuit board, and I've mounted a DB9 connector, and I'm holding it in place with goop. I mean genuine goop. I've left the LEDs intact. Of course they'll disappear when I put the lid on, but at least I'll be able to check it with the lid off and make sure communications is established. I believe this is what I need to finish up the QRP Labs signal generator. Although I can see about 20 feet behind me a bunch of the stuff that's in this package, but I can't get to it. It's a long, complicated story. So I had to order this stuff, even though I have enough of it in stock to easily complete this project. What I've got is a bunch of male connectors, unfortunately without hardware. And I've got a female by female DB9 cord. Well, I finished all mechanical construction on this the QRP Labs GPS disciplined signal generator. Mostly it consists of hooking up this switch, which is S1, and it used up the other ground connection I created. Installed the DB9 connector on the back of the case. This is a 6-foot piece of DB9 by 9, female by female, because both of these are male. I think really this should have been a female because the power supply pins are exposed. But the male was supplied with the kit, so I installed it. I may replace this socket. It seems to be faulty. I can put this in position where the thing reboots. It's not stable. This is a signal generator in its final program form. The 10 million is the number of hertz being output currently. The A means the satellites are okay. The heartbeat, of course. And then it says number 8, number 08. That's the number of satellites currently used in disciplining the signal generator. So I think maybe this will complete this series on the QRP Labs signal generator. So if you enjoyed this series, please comment, give me a thumbs up, or subscribe to my site. Thank you.